Good day, everyone, and welcome to today's webinar on the European Space Agency's EOPF Sentinel-1 sample service. We are delighted to have you all join us. This is the 8th webinar in our new series, which is designed to help a wide range of users explore and adopt the new EOPF Zarr data format. My name is Dimitri, and I'm a contractor to the European Space Agency in the consortium which is implementing the EOPF Zarr sample service. We're a team of Earth observation, satellite data, and IT experts. The service aims to offer easy access to Copernicus Sentinel data in a cloud-friendly and open format, making working with EO data simpler, faster, and more flexible. Today, we will introduce the Sentinel-1 IW, GRD, and SLC products in EOPF Zarr format. We will explore the product structures, highlighting the differences compared to the SAFE format. Typical SAR pre-processing algorithms will be explained and run interactively, guiding you, the users, through some sample usage scenarios. Before we get started with the webinar, I'd like to point out a few things. So this session is being recorded, and the recording will be made available afterwards on the EOPF Sentinel-1 samples website. You are welcome to ask questions. Please use Slido for any questions. The Slido session will be open throughout the webinar, and we will address your questions during the Q&A. You can find the link to the Slido in the chat, and the QR code is also visible in the technical support profile picture. There's also our community support forum that we invite you to access on Discourse for chats and discussions following this webinar. All right, we are ready to introduce our speakers. So we have two panelists today. First of all, Michele Klaus. He's a researcher at the Institute for Earth Observation of EURAC Research. His work focuses on FAIR principles and open source software for remote sensing applications. He contributes to OpenEO API projects as a Python process developer, community facilitator, and instructor. Additionally, he maintains the free online course Cubes and Clouds and is a contributor to several other geospatial open source projects. Hi, Michele. Lovely to have you with us. Alongside Michele, his colleague Mattia will be here to help answer your questions later. Mattia Caligari is a researcher at the Institute for Earth Observation of EURAC Research, alongside Michele. His main fields of expertise are alpine cryosphere monitoring with satellite data, image processing and classification, machine learning, SAR data processing, and SAR interferometry. Well, thank you, gentlemen. The floor is over to you.
Thanks a lot, Dimitri. Let me start sharing my screen. All right, replace screen share. Okay, good. So you should be able to see my screen. Hi, everyone again. Good afternoon, good morning, good evening, depending where you're following this webinar. Today's webinar will be focused mostly on Sentinel-1. Sentinel-1 data that with this new EOPF Zarr format can be a bit more flexible, and we'll see together how this changes how we access and process the data. So to start with the content, I'm actually starting from our main website, zarr.eopf.copernicus.eu, where we can actually get to the sample notebooks that we are preparing. So if you scroll down, where was that? Under data and tools and access data. Here, if you click on Jupyter Notebooks, you'll be redirected to the EOPF sample notebooks. This web page is basically built on top of GitHub repository. Everything that we develop in this project is open source. And if you want to look through the libraries and tools that we are developing, you could just go to this main repository. And specifically today, we'll look into some sample notebooks, which are included in this repo. And the rendered version of the notebooks is available here on the right-hand side. So as I said, we'll focus mostly on Sentinel-1. If you click on Sentinel data on the left-hand side, you'll be able to scroll through the notebooks that are categorized by Sentinel mission. We have Sentinel-1, 2, and 3 sample notebooks. And to start with, I would like to start with the Sentinel-1 SLC product, which in my opinion is the most interesting, and it's the one that really opens up multiple possibilities now with this Zarr format. In each notebook that is included in this website, you'll find this Launch in Jupyter Hub button. The nice thing is that all these notebooks are already well rendered on this website, so you can scroll them, interact with some content. But additionally, as soon as you click on this button, the JupyterLab instance that we offer will be spinned up. The notebook will be directly accessible for you, and you'll be able to interact with it. So for instance, I click on it, and now I have already my tab open with this specific notebook. In this case, I won't run it interactively because all the content that I want to show it's already here rendered. So let's start with the first part. This notebook is targeting how to access and do some basic processing for the Sentinel-1 interferometric wide SLC products, single loop complex products. And the objectives are really understand how the SLC data are being stored and structured in Zarr, how to calibrate, geocode, perform some multi-looking, and all these things that you would be do in some classic pipelines. As you might have seen already in previous webinars, these new Zarr products can be easily opened via the X-ray library, via the Open Data Tree method. And you just need to specify the engine, and then the product will be opened lazily. So it's just the metadata which is being rendered here, and not the full SLC product, which is much bigger and would require a lot of time to load. So the first thing that you notice, we have 54 groups. What are those 54 groups for? Each single group that we get in this data tree correspond to a Sentinel-1 burst. We'll look at the meaning of the burst down in another part of the notebook. But yeah, this would be the main advantage of one of the advantages of accessing the data in this format is that you can directly access the single SLC burst, which gives much more freedom and possibilities when working with this type of data. So you don't have anymore to open the full zip and then just extract what you're interested in, but you have really a direct way to access the area of interest that you're looking for. And in the name, you might see we have the product name, then the polarization and the subswath corresponding, and the burst ID that is corresponds to this particular burst. So we can also check out of course, the product location. This product is being acquired over the center of Italy. You can also get some more metadata and information via the stack metadata that are embedded in the Zarr product. And for instance, you might want to check what is the orbit direction, what is the orbit number. Those information are already included in the metadata, and you can easily get access to them. So I was mentioning that the main advantage is that now we can get access to the single burst. Just as a general recap of how the Sentinel-1 SLC product is being stored, we have in the regional safe format, we have 3 different geotiffs which are corresponding to 3 different subswaths. Each subswath corresponds in this image to these big rectangles, and then the bars are the smaller rectangles that are highlighted in red. So basically all the red ones here are the bars that correspond to a single subswath. what I'm actually saying, it's also already explained in the notebook content itself. And yeah, if you want to access a single burst, you need to select the corresponding name. Here, for instance, I'm just printing out how many bursts are in this product. There are 27. Usually, I guess there are up to 30, but I mean, this number is not constant. There might be products with a bit more or a bit less number of bursts. Okay, so we have seen a general overview of the data structure. Now let's see what we can actually do. For instance, I'm interested in a burst which is in the first subswath, IW1, polarization is VH, and I can access directly via this selection the data corresponding to that single burst. If you're not aware of it, single look complex stands for complex data. So we have data which is in complex 64 format. It contains real and imaginary parts. You might want to compute the amplitude or the intensity of the product. It's super easy. You can do it as you would do it with NumPy arrays, either accessing the real and imaginary parts separately or directly using Python shortcuts for to compute for instance, the absolute value of the complex data. The next section, I'm going through an example on how to compute the multi-look over the data. Since here we are using X-array, the X-array function that is being, that corresponds to the multi-look in this case is called coarsen. And by passing the number of looks that you want to average on the various dimensions to the coarsen method, you can compute the multi-look, which can be considered as a kind of filtering. Of course, then you would like to calibrate the data. The nice thing of the Zarr product, if you are aware of how the original data is stored in SAFE, is that you don't have any more single XML file containing all the metadata, but everything is already included in the Zarr. So for instance, if you're looking for the lookup table to perform the calibration, this calibration lookup table is already included in the Zarr product as an array, and you can access it via the quality group, and then within the quality group, there's the calibration group. Within the calibration group, you have 4 different lookup tables, and the one that we are interested in is the sigma naught. I'm also referring to some official ISO documents in the notebook itself, because I think it's really important to point any user that is going through these examples to the original guidelines and documents. So here you could actually get to know how the calibration works, what is the meaning of the various coefficients, and also how to properly compute the various coefficients, which is available at this link. Has a different resolution compared to the SLC data, and that's why we need to firstly interpolate the lookup table to have the same size as the bars that we want to calibrate. And then finally, we compute the sigma naught by this simple formula. We also convert it to decibels. Super easy to do in Python. It's just one line of code, and then finally we just plot a small subset. This visualization is still in Zarr geometry. In fact, you see that on the y and x, the dimension are still azimuth time and slant range time. Of course, if you want to work with this kind of data and then also relate it to other acquisitions in time or other missions, you would like to have this data geocoded on a regular grid. So if maybe I didn't mention it before, but the Sentinel-1 data, SLC and GRD are not projected on a regular grid, so you can't use them directly as they are. So there are some pre-processing steps that you have to go through, and one of those is the geocoding. In this notebook, we are showing a really simple way to geocode the data, since the Zarr product includes also the ground control points, which again, it's an array, it's a matrix containing longitude and latitude pairs corresponding to specific locations that we can use to then geocode the full array. Again, those are just some points, and as you might see, the dimension is not the same as the bars. So again, we need to interpolate this data, and then we'll use the latitude and longitude pairs to perform the geocoding. So in this case, we interpolate with this interp-like method with the same size as the sigma naught bars that we computed before. We assign the coordinates, and finally, we're able to plot the geocoded result. Be aware this data here is geocoded, but it's not yet on a regular grid. This geocoding or reprojection on a regular grid will be targeted in a different notebook. It's not yet here, and it will be released soon. Maybe you would question how to get to know whenever we share some new content, some new notebooks. Let me just go back quickly to the website, because on the website you can subscribe to the newsletter, and please, sorry, if you want to stay updated with what's going on in the project, please subscribe to the newsletter. So as soon as we release new notebooks, for instance, this one showing how to geocode a time series of Sentinel-1 data, you receive an email and you'll be able to test it out. All right, so we started from the single look complex data. There are other products that are available in our sample service initiative. I just wanted to show you how to get to know which data is available. You would have to look through our stack catalog. And if you go again to the website and you go under Data and Tools and Stack Browser, you'll be able to get to know which are the data collections that are available, and also navigate through them, filter, and many other things. For Sentinel-1 specifically, we have the Sentinel-1 SLC collection, the Sentinel-1 Level 2 Ocean product, and the Sentinel-1 Level 1 GRD product. Just wanted to point out that the EOPF project is still ongoing, and the actual library which is being used to convert the data from the original SAFE products to this new Zarr format is still evolving. If you are interested in getting to know how this conversion is done, and you could also do it on your computer, you could install the it's called EOPF. It's a Python library, and you could directly use it. Why am I mentioning this? I mention this because the Sentinel-1 products have been recently updated, and now we can do many things that previously were not yet doable because the product wasn't perfect yet. I'm highlighting this because on our stack collection, we might have products which have been produced with an older version of EOPF, and you might encounter issues if you're trying our notebooks with this older version of the data. Recently, our pipeline has been updated, so all the new products that are being processed from yesterday or today onwards will be compatible with the Sentinel-1 products. I'm just showing you quickly how you could understand if a product that you're interested in, which is available in the stack collection, will be compatible with the notebooks or not. So for instance, let's look through this product, which has been acquired by the satellite and processed and made available within the day, because it's from this morning at 8 a.m. If I click on it, I'll see, well, the location, and on the right-hand side, the metadata. If you scroll down the metadata, you'll see under this processing part, it's a stack processing extension. You'll see at software. If the EOPF CPM version is greater than 2.6.0, it will be definitely compatible with our notebooks. All right, so now let me go to the next notebook that I wanted to present, is this Sentinel-1 GRD, which is here. And again, as I said, you can also launch it and yeah, try it interactively. Again, we are importing the necessary modules. Here I also explicitly put a note about this. As I said, all the data that has been processed with an older version might not work. So please check. Usually it's also in the from stack in the href. So the actual URL of the data, you might see it contains CPM underscore version something. And yeah, if something doesn't work, maybe try to check out which version the data has been converted. Anyway, everything that will be processed from now onwards will be fine. So the difference with SLC is that now we don't have any more the bars. So if you ever open a GRD product, you'll get 2 different groups divided by polarization. Then for each polarization, you have the same structure that you might encounter for EOPF Zarr Sentinel-2 products. So with the 3 subgroups: conditions, measurements, and quality. Under the measurements, we have the actual GRD data. Under the quality, we have the calibration lookup tables, which basically follow the same structure as the previous ones that we've seen before. As I said, you can get access to the groups. And if you want to get to the GRD data, you can, there are different ways that you can, different ways to express different notations on how to get to different subgroups. In X-ray, this is one. The other one is the dot notation, but you get to the same data arrays or data sets. You can just use the one that you like more. Again, here we're extracting the location of the data using GeoPandas and the metadata. We can perform some decimation so that we just get, for instance, 1 out of 10th pixel to process the data quickly if we want to get an overview of the whole image, which otherwise wouldn't fit in the memory. And similarly as we did before, we are doing this geocoding, use the ground control points. But again, this is not reprojecting or regridding on a regular grid. This will be covered in a different node. Again, here we're interpolating the ground control points, assigning the latitude and longitude to the data, and finally plotting the data. You might be interested in how to actually perform the spatial slicing, because since this data is not on a regular grid and it's still in subgeometry, but you would still like to work on a small subset, well, you have 2 different paths that you could follow. Either use directly the Sentinel-1 SLC data and select the bars that is covering your area of interest. This would be fine. And from the SLC, you could get to the same level of the GRD product. Or in this case, if you want to stick with GRD, you could build basically a mask based on the latitude and longitude layers, and then compute where the data is being within your area of interest, and then basically using it to crop the data. Please be aware that this will need to be computed because in X-ray, in this case, we are using lazy loaded data. And since we need to actually access the values that are corresponding to the lat-long pairs, in this case, we really have to load the array of lat-long values and then compare them. So it's not that heavy in terms of computation, but if you have to do it for a really long time series, it might really add up some time in your processing pipeline. Yeah, and finally here we're just showing part of the cropped Sentinel-1 GRD data. Yeah, I actually wanted to highlight that whenever you have issues or questions, you can either go on the GitHub repository, open up a new issue and ask for questions. You can also write suggestions and feedbacks, or if you would like to see something which is not yet available as a sample notebooks, you could always propose something. And then as Esther said, or Dimitri said, there's the forum, the community forum, where you could always post a question. If it's not related to maybe to GitHub, you can also post a question here, and we'll be happy to help you out and trying to solve the issue that you might encounter working with this data. I think that I'll stop here. I'm really looking forward to listen to your questions. And thanks for listening. We are here to discuss the, let's say, future usage of Sentinel-1 data in Zarr format. Thanks.
Thank you very much, Michele, for those two presentations of the two notebooks covering SLC and GRD data. And I think it's especially important to highlight that you also showed how to check which data sets are going to be compatible by checking the EOPF version in the dataset metadata. All right, well, we do have a number of questions coming in from the audience, so thanks very much for everyone who submitted a question. Feel free to keep asking as we've now concluded the presentations. And I'll welcome to the stage Mattia, who's also going to help if needed to answer some of these questions. Okay, so first, there's sort of a generic question, which has been answered offline by our backend experts. The question is, do we need to create credentials to download data from platforms like GEE, NASA, and ESA since they require credentials? The reply has been given. It is, as soon as we post the question, this will be visible to all of you, but the EOPF Sentinel Zarr samples are available via an open object storage, so no credentials are needed. You are able to access this information without any additional credentials required. Then we have another question here, which is, are the bursts within each sub-swath already aligned, allowing for seamless mosaicing?
Good question. I mean, in theory, each bars should cover the same area. The location of them is fixed, but the thing is that the coordinates associated with each pixel are not the same. So you would anyway have to co-register them if you want to use them in a time series. But maybe wait, no, maybe I got it wrong. So maybe the question comes from the original SAFE product format, where you have in the same GeoTIFF, in the same subswath, the bars that are overlapping each other. And I think that currently the bars that we see here in the Zarr are still overlapping each other. So no, it's not possible to use them directly for seamless mosaicing. There will be still need some work to be done. For instance, there should be this debarst process to be implemented. This is something that might change in future. It really depends how ESA will tackle this point. Not sure if you want to add something with that.
No, you already said all.
Okay.
And just for my understanding, and perhaps for the users as well, is it the sort of thing that we could consider as the subject of a future notebook to demonstrate this debursting process?
We might consider if we might look into it. It depends if we manage to actually re-implement the function in Python.
Okay. That function is not already, let's say, available.
No.
Currently. Okay, thank you. Okay, then we have another question about the project, the program overall, if you like. So the question is, the SLC collection only covers a limited time frame, 2023 to 2025, right? Question is, will it be updated with the full Sentinel-1 archive in the near future? Because this user would like to understand whether they can update their operational processing pipeline to download data from this platform instead of the ASF service.
So this is not an operational platform. I mean, our project has been called the EOPF sample service because the idea was to provide some sample data that will be tested by us, by users. Maybe we'll find bugs and things to be fixed. I can't give you a time when the user will start process the data regularly. On our side, we are processing the data globally for a period of 3 months. So after 3 months, data will be deleted. And the SLC collection that you're checking, it seems to cover 2 years, but in fact, it's not, because it's covering only the data that we requested for the sample notebooks to be processed. So explicitly, we asked for a list of data to be available, plus these 3 months of data, which is regularly updated. So there's no currently fixed date when you'll be able to do that. And that's something you'll need to ask at ESA. Maybe post a question in the community forum, because also ESA is reading those questions.
That's a really good idea, and it would also give us a place to pin and send people to look at for ongoing discussions and updates. Of course, ESA is, I mean, this is a dynamic program. Things are moving and decisions are being made as we progress. So that's a very good point. Thanks. So that's answered. Then we have another question here. In the Sentinel-1 GRD datasets from the European Open Science Platform Foundation EOPF source. One correction here, EOPF in our case stands for Earth Observation Processing Framework, not European Open Science Platform. Not to be made, that distinction, one has to be careful. The question is, are the processing steps implemented such as thermal noise removal, radiometric calibration, and terrain correction?
Yeah, so short answer, no. For thermal noise, we actually looked into that. There's actually an issue with the product itself, how it maps the metadata from the original save to the Zarr. So the EOPF developers working on the library to convert the data are working on that to fix this issue, and after that we'll be able to implement firstly the thermal noise removal. For the radiometric calibration, I think that we already showed that. So it's possible to perform it using the lookup tables. And terrain correction, no, not yet. That's something would be nice to have in the future, but currently it's not available.
Mm-hmm. Perhaps another good candidate for a community support post where updates can be provided in the future.
Yeah, please post those questions, because the more you show interest in these products, maybe the higher the interest also on the ESA side to push for these things to be developed.
Yeah. Just bringing this one forward, it's a clarification to the question that you just answered. The question is, the 3 months availability, is that from today, counting 3 months backwards? And the user reports that the data from 1 week ago sometimes is not accessible, right?
So as far as I remember, we should have a window of 3 months where the data should be available. Of course, in theory, the data of 3 months ago should be available, and and it will be later on deleted. I can't tell you more, but if you have a specific issue with some data collection, maybe please send us an email or write on the community forum or GitHub, so we can look into the reason why the data is not there.
Okay, so maybe something with the specific case. Okay, let's have a question here. This one says, do you plan to create in-SAR examples using S1 Zarr data?
It would be nice, indeed. I think that the missing component currently is the co-registration. So as soon as, let's say, we'll be able to co-register the data which is proposed and available in Zarr, it would be quite easy to do that. Maybe I'll just anticipate. Currently, what's missing is the compatibility with the Snap software. So whenever Snap will offer the possibility to open the data from the EOPF Zarr format, this will be directly feasible with Snap.
Okay. Thanks.
Maybe we could also add another thing. So there are other products that the EOPF project is currently working on. Do you want to mention them, Mattia?
Yes, so basically, related to the exploitation of INSAR products, there is some work that is doing in the direction of offering a already co-registered single loop complex product in SAR geometry, and also geocoded single loop complex product. So basically, these are higher level products starting from the SLC data that allows for easy exploitation of interferometry or generation of interferometric products. But as far as I know, at the moment, they are still not available.
I'm sending a link with the documentation of these upcoming products in the chat. Dimitri, I can't send the message to everyone, but I think that later on
we can, yes, we can include that link in the question and answer follow-up that is published on the website as well, in the same place as the webinar, so you'll have access to this link. Thanks. Okay, still getting some questions in. We are closing in on the end of the official timing, but okay, let's see. So will there be an official analysis? Oh, sorry. I archived that question by mistake. I'm sorry. Here we go. There we go. So will there be an official analysis ready data product from ESA, EOPF?
Indeed, yes, it's planned. We don't know the timeline yet, and there's this documentation page that Mattia mentioned where they mentioned the upcoming products, and one of those is the analysis ready data terrain correct, radiometrically terrain corrected product that should be available sometime. We don't know yet the actual time, but it should be.
Mm-hmm. Okay. Within the life of the samples project, of course, and thereby subject to the same testing and user validation that the other products are. Okay. Do you have Sentinel-1 Zarr product processing examples using Java, e.g. JZAR or Zarr Java?
No, not yet. The project is mostly targeting Python since we are using DAS for parallelization. But the sample data is there. You could try to work in that. We do have libraries. We developed libraries and plugins for GDAL to read directly the EOPF Zarr format. And there's also work to be done in Julia and Dar, which I'm aware, but not for Java.
Mm-hmm. Okay, thanks. question is, what will the future of the existing unofficial S3 buckets in US West 2 be? By when should we switch our pipelines to support the new data delivery system?
As we already
Sounds a
mentioned
bit
before, we
Yeah.
can't give you any timeline since this project is not gonna be the one which will offer the long-term archive. And I don't know I mean, I don't know these buckets, and I can't tell what's going on with them.
Thanks. Okay, the EOPF CPM for the SLC, can it do a conversion from safe to Zarr? Is this correct? If so, could this conversion be made available such that we users can do the conversion on already downloaded archives of safes, making them compatible with the notebooks?
Yes, definitely yes. If you look through the EOPF, if you go to PyP for the EOPF Python library, you'll see, you'll also find the link to the documentations. And within the documentation pages, you'll find snippet codes on how to convert the safe data to Zarr. So everything's open source, you can definitely try it out.
Excellent, thanks. Okay, user here works with Sentinel-2 I2A. When they query, they can see the items and their IDs, but once they want to access the data tree, the assets are not available. They will also send an email, but perhaps you have a comment, Michele, or indeed Mattia.
I don't know. I know that since I mentioned this 3 months window of data which is being processed and made available, maybe it might be possible that the actual data is being deleted, but the stack metadata is still in the catalog. So maybe the metadata is there, but then you can't access the data because it has been removed. So if you send us an email, fine, we'll also check that. And we also might check internally why this occurs.
Excellent. I said Sentinel-2 I2A as opposed to Sentinel-2 L2A, of course. Last question. What's the recommended EOPF Zarr chunking strategy for Sentinel-1 GRDH dual polymetric decompositions with neighborhood operations in distributed task processing?
I can't give you suggestions. Maybe just one consideration. There's a default chunking of the EOPF Zarr data, which is being converted to GRD. So firstly, I would suggest you to check out what's the actual, how the data is being chunked and stored. And then, yeah, for this, I don't have other suggestions, sorry.
Okay. All right, well, thank you all for your questions. We've reached the end of the list of questions, and we will therefore move to wrapping up. So first of all, once again, a big thank you to Michele and Mattia. Michele for the presentation of the notebooks, Mattia for joining us in the Q&A. I'd like to mention again that the recording of this webinar will be available on our website. If you have any further questions, you should feel free to reach out. You can do that via our community support platform, where others will also be able to connect and comment. And we'd like to invite you to our upcoming events. So the 9th webinar of this series is scheduled for the 13th of November at 1400 CET. This will be about sample spectral clustering for land use classification using Sentinel-2 level 2 data. So our user perhaps earlier asked the question, might be interested in that. So we will have Mohammed Al-Bughaddadi and Dean Summers presenting. The other thing I'd like to say is, as Michele already mentioned, you should certainly subscribe to the newsletter, because there you will receive the updates on new products and new plugins or tools, new notebooks that we're releasing, as well as information about the webinars that are upcoming. And before we close, I'd like to ask you for your feedback. So we have a short survey, which is available on Slido. You should see it if you open the Slido. One of the options is to answer the questions in the survey. Please do that so that we receive your feedback about the quality of the information that we're providing to you, and indeed on the program as a whole. Right, well, thank you all for joining us today. I do hope to see you at future events, and have a great day. Bye-bye from us.